My name is Kavita Braun, and I'm a mechanical engineer.
I'm Gabby Zamoyski, and I'm a mechanical engineer.
Hi, I'm Gregory Morrison. I'm a mechanical engineer here at FAU.
Hello, I am Daniel Carrillo, a mechanical engineer here in FAU.
The Senior Design Capstone Project is a rite of passage in the engineering curriculum. It's a project that's done over the course of 8 months. It's the first time you're doing a project without carefully crafted guidelines from your professor. I've lived in Florida my whole life and wanted to do a project that's impactful and meaningful to the state I've called home for over 30 years. One of my favorite memories is sitting on the beach the night of July 4th about 12 years ago. I felt something crawl across my hand and checked to see what it was before flicking away what I assumed to be a bug. It was a newly hatched baby sea turtle, and within minutes, dozens of other baby sea turtles had risen through the sand. My friends and I turned off all the lights, gave the hatchlings some space, and watched them take their brave first steps. Witnessing this is a testament to how far sea turtle conservation has come in the state of Florida. I first contacted Dr. Jeanette Weineken after reaching out to the Loggerhead Marine Life Center. Dr. Weineken is the director of the FAU Marine Lab.
I am Jeanette Weineken. I'm the director of the FAU Marine Lab and a professor of biological sciences at Florida Atlantic University. And the reason why we need good conservation is sea turtles have been around for about, I think the oldest ones that have relatives today are about 130 million years old. We're at a period now that over the last century, the numbers have plummeted so severely. Basically, Florida is one of the most important nesting beaches in the world. About 85% of all loggerhead sea turtles are hatched in Florida that enter the Atlantic Ocean. That's a big deal. So what happens in Florida drives what happens to the species in the Atlantic Ocean. So one of our main ideas about how eggs might communicate is by movement, because the embryos do move inside those eggshells, and because the eggshell is flexible and they're all packed together, we expect there's kind of be a bit of a propagation of movement throughout the nest. Okay, how do you test that idea? One of the ways you can test it mechanically is to start propagation and see if it's propagated across the nest. Being able to test that idea, if we can then understand what's coordinating the nest, that helps us understand what's going on under the sand, and if there are threats we don't know about, if there are mitigation ideas for conservation we haven't thought of, because we just, not knowing is a problem. And this brings us back to, if you're trying to conserve a species, you need to increase production. If you need to increase production, you need to understand what the problems are and what some of the solutions can be.
Perfect. My team pitched a couple ideas to her. After some back and forth with her team, we settled on building a system to help them study an emerging area of research.
The purpose of this project is to create a system that will measure and changes the pressure within a loggerhead sea turtle nest to study the effect of egg-egg communication. The idea is that as each of the eggs mature during incubation, the eggs exert an ever-increasing pressure on the siblings, and there's a point at which all the eggs synchronize and develop and hatch together.
Can our system participate in this communication process and influence nests that may be at risk if otherwise left alone?
The project can be evaluated in 2 parts: the control module above sand and the in-nest actuation module below the sand line. Below the sand is the heart of the system. On one side of the nest are sensors reading input pressure, the natural pressure exerted by the turtle eggs. The other side of this nest contains a system to actuate a counter pressure in response. The system measures the propagation of pressure in the nest during the incubation period. The soft actuators are inspired by the soft robotics research done by Dr. Eric Engenberg's robotics lab.
The system is fabricated in several steps. First, the white silicone is cast into 3D printed plastic molds. The silicone rubber compound is allowed to cure. After all the molds have cured, they're then fit into the wall. Each mold is attached to a valve and a pump. The whole system is run using a teensy 3.6 microcontroller. The 4x4 silicone wall was modeled to replicate the size of loggerhead sea turtle eggs.
Every season, conservationists relocate nests where the mom has laid the eggs too close to the shoreline. Otherwise, the eggs would drown. The smart system will be put in place where a nest is to be relocated. The system is designed to be implemented for the duration of incubation and powered by a solar panel. It will actuate using a proportional controller system with appropriate fail-safes to ensure nest safety.
Overall, conservation matters because if the population of sea turtles continues to decline, there will be major negative impacts on the delicate marine ecosystem and untold ripple effects. SMART provides quantitative data about pressure and propagation during incubation. The system uses soft robotic technology and is designed to be sensitive to the environment. It will be implemented on nests that are relocated and use solar panels to power it.